Hello, this is Jennifer Martinez, and today we're going to go over section 3.2, quadratic expressions. And in this video, we're going to start with you guys trying exercise 1. So it says fill in the table and draw a rough sketch of each function and then answer the questions below. So go ahead and take a few moments to see if you can do this, and then I will go through it with you. So pause the video, try it, and come back. So here is the tables. Did you guys get the answers? So if you did not get the answers, please go through them again. I'll just go through a couple of these. If you plug in 1 here, plug in 1, what do you get? You get 1 minus 2 and a 1 minus 4. So that is equal to 3, negative 1, negative 3. That's how you get the 9. The 2 is obviously 0 because 0 times anything is 0. But we can do these on the calculator. Let's try this on the calculator. What you can do is you can click on y equals, if you remember, and type in this function. So I'm going to type in a 3. I'm going to hit my parentheses, the x minus 2. So I'm going to hit the minus sign, a 2. In the parentheses again, and then x minus 4, and complete that. So I have it look like, you can't see the whole thing, but if you go back, maybe we have to hit this arrow to go back. Hopefully there will be a 3 in front of there. Let's see if there is. My calculator is a little slow. There it is. So you can see the whole thing. So sometimes it runs on if it's too long of an equation. So we're not trying to graph it yet. I just want to make a table. So remember, there's a table set. So what I'm going to do after I type in y equals, I'm going to go to table set. So here are the instructions. Table set is if you hit second, it's right above the window. Go to table set. I'm going to make sure everything is on auto. If it is on auto, great, just hit enter. But if it's not, go to the place where it's not auto and make sure that it's on auto. And then you can leave. You can go to second quit. If you choose, you don't have to. So then I'm going to go to my table, second table. Let's try it, second table. Oops, I went to graph. Second table, that'll be the next step. It's not doing it for some reason. There we go. So you have to hit the second button to get to the table, and then you should see your table. 1 is 9, 2 is 0, 3, negative 1, and so forth. So you could do the same thing with this one. Now let's plot our points and see what we get. So 1 is about a 9. 2 is 0. 3 is negative 3, so it's in between the negative 2 and the negative 3. 4 is 0. And 5 is back to 9. What we get is a U-shaped curve. This is what a quadratic equation looks like instead of a line. This is called sometimes a parabola. Just like a linear equation has lines, quadratic equations have parabolas. So let's try graphing the next one. Oh, actually first, let's see if that's what the graph did look like. Let's go back to that. It did, because if you look at 1, 2, 3, is that lowest point there, and it goes upward. And how do I get the graph? You just click on the graph button, and if it's a screen you don't like, don't forget that you can go to Window, or Zoom, and then I chose 6 for standard. So now let's try the next one. So first I'm going to check the points. So I'm going to go back to y equals. I'm going to clear this graph and I'm going to type in our new function. The only thing that's new here is you have to do the square. Right, go to y equal, type it in, and then plus, and then don't do -4. Make sure you remember there's a negative. You have to do a -4. So if you look at that, where is that? There it is, -4. You could put that in parentheses. So I'm going to go to table set, make sure everything is on auto. Should automatically be on auto last time. I don't know why mine isn't, but I'll put it on auto. Then go to second table, and then those should be the values of those. Let's go and graph those. So we have 1 is -4. So I'm going to graph that point. 2 is -1. 3 is 8. And then 4 is 23. That's a little too big. That's harder to tell what the values are. So what I'm going to do is I'm going to do one more point here. Let's call that g of x. I'm going to do 0. Because when you plug in 0, what would you get? You would get 3 -1 squared minus 4, so that would just be -1 squared is 3. 3 minus 4 is -1. So that right here is a -1. So you can see that is a parabola, but it's just harder to find. Let's look and see if that's what we get on our graph. Let's go to graph. Sometimes it's just easier to do it that way. And you can see there, that's what it is. Maybe I'm going to zoom in. Let's go to zoom 2 for zoom in instead of standard. Press enter, just so I could see it a little bit closer. You can't see that bottom point, but you can see that it does go through a little bit bigger than 2. And it does work. Okay, so it's still a parabola though. We're going to see it in the future. So for part A, in the formula 3x minus 2 times x minus 4, how did the 2 and 4 affect the graph? So if you notice, they are the x-intercepts. The x equals 2 and x equals 4 are the x-intercepts. Notice how, if we look at, actually it's right there, we don't have to go back up. If we look at this formula, the 2 and the 4, here's the graph for part A, are the x-intercepts. They were where the y was 0. Makes sense. Where the y equals 0. So that did make them the x-intercepts. In the formula g of x for the second one, what did the 1 and -4 do? Notice how here is the opposite signs on this one too, but in this one it's not. That's why they put plus -4. But anyway, if you look at what 1 -4 is, it looks like it's the vertex. This point down here is called the vertex. The lowest point or the highest point on the graph of a parabola is called the vertex. So the point 1 -4 is the vertex. Which brings us to the following formulas. This is called standard form. This is called factor form. And I'm going to add here what we learned. R or S are the x-intercepts. And then this is called vertex form because H comma K, the opposite sign here but not here, is the vertex. The A, B, and C do not tell us anything. They are just the coefficients. A, B, and C are the coefficients, but they don't tell us anything about the graph. There's one more thing I want to tell you about these formulas, is the A. Notice how you have an A here in all three of those. The A tells you whether your graph is going upward or downward. Both these examples were upward graphs, upward parabolas. And notice on both of them, the A's were 3. But if your A is negative, the graph is going to look like this. It's going to go downward. So that's something to know. Again, if your A is positive, it's going to go upward. Let's look at an example of that. Let's look at y equals negative 2x squared. So the A is always the coefficient in front of the x squared. Well, if I go ahead and graph some points to that, I'm going to just graph these 3. If I plug in 0, I'll start with 0 because it's easiest. We know it's 0 because negative 2 times 0 is just 0. If we plug in a 1, it's negative 2. To see that, I'm going to plug in a 1. 1 squared is 1, and negative 2 times 1 is negative 2. Even if I plug in a negative 1, it's negative 2. To see that, because negative 1 squared we know is 1, and we still, you can see, get negative 2. So if you look at the graph of this, just real small here, 0 is 0, 1 is negative 2, and negative 1 is negative 2. You can see it's probably going to look like that. Or you could graph it on your calculator and see how that looks. So if you go to y equals and plug in a negative, and again, it has to be that negative key, negative, not minus, 2x squared. And I'm just going to go straight to graph without making the table this time. And see if it does indeed go downward. There it is. Versus if you plugged in something that's positive, like on y2, let's plug in 2x squared and see if that is indeed upward. So again, when the coefficient in front of the x squared is positive, it goes upward, and the coefficient in front of the x squared, one of these a's, is negative, it goes downward. This is going to be very useful in our next example, which we'll see in our next video.